All right, can you hear me and can you also see my screen?
Yes and yes.
All right, well, I appreciate the invitation to come and speak today. And I know it's better where you are, but where I am in Champaign, we've got incredibly thick fog this morning. In fact, it looked as though it rained last night, even though it didn't. So it's kind of a mixed bag across the state here. But Megan asked me to come and speak today. It was to discuss some of these big issues about climate shifts, climate disruptions, and really its impact on corn production. And I've spent a lot of time over the last several years just trying to figure this out and understand it in a way that I can help communicate what those changes look like. So I thought that's what we do this morning. And I really want to share with you what we've observed over the last anywhere between 40 to some places going back over 120 years to understand what those shifts look like and if there's significance to them that we should pay attention to. And that's what we're going to cover. So I'll open this up to any and all questions as we kind of roll through this today. So let's just get started with the big question here. We look back since 1980 at US corn yields according to NASS, and we have this beautiful upward trend in yield. And when I fit a linear curve to it here, what I end up finding is it's about 2 bushel per year. And a lot of this is really driven by the I states. Our total productivity and our bushel per acre numbers just push this to the limits here. In fact, if you were to detrend just the last decade or so, that slope, as you see over here on the right-hand side, is even higher. But a lot of that's because of the big event we had back in 2012, massive drought, of course, which we all have fresh in our minds. Most of this is a technology curve, but we know that there's some pretty cool things that cause a lot of variability around that, and that's what I want to talk about. Is the variability around the line is mostly driven by weather. I want to be discussing that. Now, when I think about Illinois, okay, and growing a crop in Illinois, I think about what we've got here. And this was a couple years ago, back in June of 2019, where I watched this field over by the Embera River in Champaign County here. I watched a guy put in what's called a saturated buffer. And what I was most amazed by when changing his drainage strategy here was we had to dig down about 9 feet to put in that box you see there. It's especially, you can see it a little bit easier there over on the right. And we didn't hit clay. It's amazing just to see how deep the topsoil is here and how in some places it's so incredibly rich. And we can thank our last glacial time period, about 20,000 years ago, for kind of depositing a lot of the sediment here. And then remember, after that glacier retreated, we had very, very windy conditions for, several thousands of years. It's crazy to say, but several thousands of years coming out of the plains that blew a lot of the topsoil over from, Kansas and Oklahoma and Nebraska and deposited here in the Midwest. And so, when we just think about this, we know we have the productivity out of the soil. What we want to ask ourselves is anything changing in providing, water and sunshine to that soil to get the crops to really grow here? So just a fun video to kind of start off with. So if you've ever wondered what our climate classification is, what you've got here is you've got what we call the Köppen climate classifications. And these are the ones across the United States. Now, there are no state boundaries, but I labeled the two big ones for Illinois. The one to the north is labeled the DFA, and that basically stands for warm continental climate, but humid continental climate, which means we've got plenty of moisture that comes up from our nearest source of a big body of water, which is the Gulf of Mexico. In the southern part of Illinois, we have a CFA climate classification, and you can read down here that that's a warm ocean climate, with also called a humid subtropical climate, which means that this is just far enough to the south that we have extended and long growing season between frosts, and but plenty of moisture. In fact, there's big forests in southern Illinois getting over toward, the Ozarks and just to the south on the Mississippi River. And it turns out that our soils plus our position in the mid latitudes here actually makes us just perfectly suited to grow what we grow. And I want to show you what we get in terms of normal precipitation. So every decade we update what we call our 30-year normals. So this is like any day that they say, oh, the high temperature on average is this, or the total, the average amount of precipitation today or this week or this month or this year is X. We get that by averaging a 30-year time frame. And we're going to ask a question in a few minutes as to, is that 30-year normal shifting? Because if it is, we need to know about it. But generally speaking, the northern half of the state ranges between about 36 and 40 inches of precipitation annually. And again, that's when we melt down the snow to liquid equivalent, so that gives you some perspective there. And in southern Illinois, it can be between 40 and 50 inches. And most of that moisture, the vast majority of it, is going to be coming from our nearest large body of water. Like I said, it's Gulf of Mexico. I just want to show you, this is actually tonight. This is a forecast of something called precipitable water. Now, I want to come back to that particular metric, that particular variable in the atmosphere in a few minutes. But if you notice, see this region right in through here, where we have very high precipitable water amounts. And that means how much moisture could be wrung out of the atmosphere to make precipitation. Well, tonight we're opening up the Gulf of Mexico to return that moisture to our area. And we have a large region in through here that has a severe weather risk. So we could see some pretty nasty storms coming through this area tonight. And that's another question we're going to ask and answer. Are we seeing increased frequency of those storms throughout our growing season? But tonight we're really opening up the Gulf of Mexico and bringing that moisture in. And this is what we've got. Just to give you a quick forecast here, if I had the day off, I would head down to I-70, to be honest with you, and do a little storm chasing tonight, because I think that this is going to be the area that's going to see some pretty active storms. It's very difficult to storm chase south of there. This whole area, you all know there's quite a bit of forest in here, and the road network's quite difficult, but I think there's going to be a pretty rough go of it down there. And I can show you what I'm talking about here. Here's a forecast from one of our high resolution models. So while snow spreads throughout the plains today and ice in parts of Iowa, by tonight, we're going to see the warm front lift through, and then you can just see the models are putting out some storms in through this area in the overnight hours, and then when the front sweeps through, could get some thunder here early in the morning sweeping through this part of Illinois. And we're just concerned that throughout the evening hours, when the sun's down, we could get some tornadic thunderstorms. It'll cool off behind this, but trust me, it will not last long. I got some very warm conditions coming in behind this next week, as Megan was saying here just a few minutes ago. Okay. With that out of the way, let me give you some numbers. Now, I know that these two maps the numbers on them are very small, and I hope you're playing this in full screen so you can see it. But I thought what I would do today was I would just kind of go through a season. Let's talk about spring. Let's then get into summer and fall, and then we can talk about winter at the end and actually do a forecast. It'd be kind of fun. So the Illinois State Water Survey, and by the way, we have one of the best state water surveys and climatologist offices in the country. I'm so proud of our guys here in Champaign and the work that they do. But looking at the historic first and last frosts, we can see the dates. Now, I'm going to send this presentation out so you can take a closer look at this and even visit the link at the top. But let me just give you a couple of numbers here. Where I'm over in Champaign, on average, 9 out of 10 years, our last frost in spring happens before April 27th. And our first frost in fall generally happens after about the 26th of October. Now you get into the northern part of the state, let's go up by Rockford, knock off 6 or 7 days. It's about the 20th of October. And then spring, take a look at this. We can sometimes get our last frost here, I mean, this is the second week of May that we can sometimes get that. So there's a huge disparity in our very long state here of the first and last frost dates. But we've been trying to study if those things are changing. And I want to give you some numbers here. I just went and pulled off some data I've got from Bloomington, Illinois. Now, when you look at this graph, there's a couple of cool things on it. We're looking at growing degree days. And I start calculating from the beginning of the year. Now, on this graph is mostly 2021 data in that thick black line, but I put on here 2020 all the way back to 2016. And then you see these blue bars? Those are looking back over the last 40 years when we had frosts. So for example, right around the 15th of April, there were actually, you see up here, 3 different times in the last 40 years that day had the last frost. So this is kind of your distribution of last frost events. And this is your distribution of first frost events. So the earliest we've had, it was actually in September, and the latest was all the way into mid-November, all right? Now here's the thing. I went and looked between our latest last frost, which actually happened in Bloomington on the 29th, or excuse me, the 28th of May, and the first one that was the earliest, which was on the 23rd of September. And even with that short of a growing season, we still hit 2,500 GDUs, okay? Normally, we get anywhere between 3,000 to some years upwards of 3,700 GDUs. But the average between the normal last frost and first frost is about 3,250. Now, why I bring this up is because that means that Illinois' climate, based upon the typical maturity ranges we have for corn, it's very, very rare that we have a frost event destroy the entire state's worth of crop. In fact, maybe the last time that that occurred was back in 76? And other than that, I mean, even think about how late we planted the crop in 2019. Some of the crop didn't go in until June, yet it still reached a maturity because there's just enough heat to get here. So this is a very suitable place for it. But thinking about that frost-free season, I'd like to show you just some data that we've collected all over the state. And I'm just going to pick a weather station here in Urbana, Illinois, just close to home for me. And we have some weather stations in the state of Illinois that have actually been collecting data for over 130 years. The one in Urbana is one of those stations, but I decided just to pluck off 1900 to 2021. And what you see here graphed out, the y-axis tells you the number of days between the last frost and the first frost. And then I put a trend line on it because annual variability is high. But I wanted to know if it was increasing or decreasing, looking back over a very, very long time period. Now, certainly when we go back to 2020, because of that very late frost event that we had at the end of spring, and then the early one, that was highly anomalous. Because generally speaking, in central Illinois, we've added about 9 days of frost-free season. So you want a statistic today? I'm going to give you several of them. Just based upon weather station data, many of which we have going back to the year 1900, even before, much of our area has added about 9 days to the frost-free season. And we've seen some adjustments to this. A lot of folks will choose to plant their crop earlier and earlier based upon, some really amazing seed genetics, but also the fact that generally speaking, our first and last frost dates are getting, closer to the beginning of the calendar and closer to the end. Now, this has been studied by we have a panel, not a panel, a group of authors that are peer-reviewed scientists that published an incredible repeating publication, that's up here. It's called the National Climate Assessment. And their globalchange.gov website is where I pulled this figure. Because what I want to show you is good science is when we have repeatable results. So when they came out and said that our region was about 9 days more than average, I said, well, I'm going to go into the data and prove that. That's good scientific method. And sure enough, it matches what they've got here. But take a look at the Northeast, look at the Northern Plains, and come out here into the West. There are some places that have added between 10 and 20 days to their frost-free season. We look at those changes and try to understand their impact on a growing season. And it's one where an increased frost-free season tends to lead to much higher yields as it allows us to plant earlier and earlier. Since we're in spring and we have such rich data across the state of Illinois, I thought I'd show you what happens to our average temperatures in spring before we talk more about precipitation. So this is April and May only, and we're looking at the whole state of Illinois and the average temperature. Now, again, there's a lot of year-on-year variability, but I'm interested in the trends. So I decided to show you in blue what the trend has been since 1980. I was born in 1980, so I just started at that time period, but 41 years worth of data. And what you see here is that we've increased our average temperatures about 1.5 degrees. That's about 0.3 degrees Fahrenheit per decade. That's been the trend. So this is part of that equation. We're seeing these warmer overnight lows, which just means that our last frost in spring is happening earlier and earlier, and it's shown up pretty clearly in the data. Now, again, there's a lot of variability around this, but that upward trend is the number that we want to be thinking about. Now, how about precipitation? So looking at the same data set, and again, this comes from NOAA, April to May, I put a trend line on 1980 to 2021. Now, this is a bit different. The inch per decade trend is almost 1/2 inch more. So when you look back here at 1980 to present, we've added almost 2 inches to our spring rainfall. We've increased the frequency of rainfall events where we get more than 1/4 inch of rainfall a day in April and May. We've also really increased the number of days where we get more than 1 inch. So what I tried to do with this was try to understand how that impacted our planting progress. And using the definition provided by the USDA, I went out and looked at what we call workable field days. And because of the increased frequency of the heavy rainfall events, but also just the increased frequency of rainfall events more than 1/4 inch, We now have 2.5 fewer dry days, but we've also doubled the number of days where we get more than an inch. And talking to some farmers, I said, if you get an inch of rain and it's in May or April, how long does that typically chase you out of the field where you can't get back in? And the general consensus was between 2 and 3 days. So using that farmer anecdotal evidence plus the USDA numbers, this is what I've come up with. Since the 1980s, we've lost about 5 days, workable field days, in April and May across the state of Illinois. We've made up for that with just bigger and badder and faster planters. And as a result, when the windows do open up, which they do, okay, we can just really, really crank through the field and get things going. 2019 was a very rare year for the state of Illinois, being so wet that we could not find those planting windows. That was a very rare event that we saw in 2019. And it required very special weather conditions that I don't foresee happening next year at all. Just something to think about there. But let's continue on this discussion, because ultimately why we study all these things is we want to understand how is this affecting, yield variability. So the map you're looking at here was one that I produced looking at corn yield variance since 1980. So states that have very low variance, or counties that have very low variance, shown in blue here, are often counties where they have tight controls on the water, primarily through irrigation. Where you get into these redder colors represents states where usually it's all dry land farming, and they have a climate that is not exactly that hospitable to growing corn. So specifically here along the East Coast, down into the Southeast, Texas, the lower Mississippi River Valley, parts of Missouri, the Northern Plains. But there's a sweet spot right in through here where variance is relatively what I would call normal. Our yield varies within a relatively small range. And that's also coincides to a place that has just the absolute best soil, in my opinion, on the face of the earth. And so these are just things we're looking at. We want to know, is anything going to change that yield variance in corn with time? So if we get into summer, now that we've taken a quick look at the increased temperatures in spring and the increased rainfall, I want to show you what we have to worry about every summer. And I'm going to pluck off some scary years here. Actually, I'm going to pluck off one scary year and then a fantastic year. You see, every summer we watch the temperature profile for every location that grows corn. And I'm going to tell you something. When you look at these temperature graphs, which start at the beginning of the year and go to the end, and there's a blue bar for every day that represents the high and the low. We then see the record low temperatures down here in this shading and the record high temperatures there. What you want to be on the lookout for in June, July, and August are what I call the V's. Actually, I should call it the inverted V's, where the temperatures and the pattern looks something like that, where we have a peak in our high temperatures coinciding with pollination, which is generally the end of June or the beginning of July. You notice back in 2012, we had several days that topped 100 degrees. And in addition to that very hot temperature with high evaporation rates, we were also under a big ridge and very dry. In fact, the jet stream pattern in 2012 placed the ridge right here, almost over the Red River Valley of the North, so that the jet stream did something like this. And then it went way up here into a big ridge over between the Hudson Bay and Greenland. And what ends up happening is the flow has to go around those ridges. And as a result, we were just stuck in no man's land right in through here where we just weren't getting the precipitation. So that weather pattern setup in summer is what gives us what, again, we call the inverted V, the highest temperatures happening when the corn needs it to be cool. And in 2012, we had multiple days that got well past 100 degrees Fahrenheit. And we've learned over the years that 97 degrees Fahrenheit is an afternoon high on 3 days or more in a row during pollination peels back yield at a pretty high rate. So those are the V's. What are the M's? Well, let me show you two examples. We all remember 2014. That was when on the 4th of July in Illinois, in fact, I was in Chicago on that day and it was 74 degrees as the high. What we're looking for here is an M. See how it goes up, comes down like this, and comes back up again? During pollination in 2014, we just, well, where was the ridge? It was here. The trough dipped down like that and then rose back up over parts of Greenland to the Hudson Bay. But it was this trough of low pressure that brought in the rain and the cooler weather. You see, every single year that we hit above trend yields, it is almost always going to give us an M shape in the temperature distribution throughout summer. The years that we have terrible yields because of heat and drought, they are inverted V's. So what was 2021? You can see it here, right? Came up like that, came down a little bit, and went right up over like that. So we just avoided the extreme heat. And I'm going to tell you why in just a few minutes, how we avoided it. But a lot of it had to do with putting a big ridge here. So the flow of the atmosphere came over that ridge. And because of that, we were not in the center of the greatest heat. It was in the west part of the United States. So see, that's what we study every year. Here's the question, because you asked me to talk about climate change today. Are we seeing more frequent M's or more frequent V's or inverted V's in our temperature pattern in the state of Illinois? And I want to give you an answer to that, because this past year, take a look at what the atmosphere did in June. It rose up into a massive ridge here at the end of June, parked right over British Columbia and Washington. And the flow came down into a deep trough that went straight across Iowa and Illinois. Now, on the southeastern side of that trough, remember at the end of June, this is where we saw in some places 10 to 12 inches of rainfall in parts of Illinois. All the heat was way over here in the west. In fact, parts of the Pacific Northwest broke all-time records. From June 1st through August 15th, every climate reporting district that has the number 1 in it, that was the warmest such June 1st to August 15th time period going back to 1893. And all the heat that went into the west, I mean, Portland, Oregon hit 116 degrees Fahrenheit in late June. And what did we get on this side? Rain and cooler weather. Now we need to talk about some of the factors that came together to make that. But first, let me give you some stats. In summer, which I'm defining as June, July, and August, are our temperatures changing? Again, went back to 1895, but detrended the 80s through present. And what we've seen since going back to 1980, just as an example here, is that our overnight low temperatures have really risen well more than a degree. Now, what's the point in telling you that? Our temperature trends in the state of Illinois in summer are warming overnight. When is it going to start to be a problem? It appears that at about 30 to 35 years from now, if you continue out this trend, we will average overnight lows in June, July, August that will be approaching 70 degrees Fahrenheit. But that's still 35 years away before that trend really starts to give us problems. So in the meantime, these warmer overnight lows, you know what they're doing? They're actually warmer because of increased moisture content. We've increased our dew point temperatures. I'll show you that in a few seconds. But you may say, well, what about those maximum temperatures? Well, this is what the maximum temperatures look like. Going back to 1980 and moving forward, the trend in our maximum temperatures is actually down. It doesn't mean we don't have hot years. I mean, you can see, look at these hot years in through here, hot summers, excuse me. But overall, you look at the whole distribution of temperatures here, the trend is down, very, very slightly. Now we start to ask ourselves, why is our maximum temperature trend down, but our minimum temperature trend is up? Because the net effect is our average temperatures have increased, right? If you just put the max plus the min divided by 2, you know, the greater change in the minimum temperatures lead to an overall warming. But most of the warming is happening overnight. Let me show you what happened this year. Since we just talked about precipitation a moment ago, let's see what happened from June 1st to August 15th. Where that ridge sat in this area, you can just outline very easily where the driest locations were. See that? Where the trough then dug down and then shot like this, gosh, from Missouri through most of Illinois into Michigan, extremely wet at times in the middle of this summer. In fact, I was keeping track of it just from, I actually do this for 30,000 locations in the US, but in Champaign, this was all the heavy precipitation that came in at the end of June and beginning of July. Took our precipitation curve from being a little bit below average to well above average, and we've just stayed there for the rest of the season. In fact, we're currently sitting at 108% of average on precipitation, even despite how dry the month of November was. So we ask ourselves, is there some sort of canary in the coal mine? Is there some sort of indicator as to what's causing this change? And I'm going to tell you to look west. This is looking at the current reservoir conditions back at the end or the middle of October. Lake Shasta, Lake Oroville, two of the biggest reservoirs, were sitting at 22% of full pool. And I want to know, is there some sort of relationship between what happens in the West and what happens in the Midwest? Because whenever it seems to get really hot in the West, we tend to have the opposite effect of it here in the Midwest. And in fact, this past year, in the middle of summer, we saw a lot of fire activity again. Now, compared to average, there was about 1.6 million fewer acres burned this year compared to the 10-year average. But it didn't mean the fires were any less terrible, especially in their contribution to smoke. This is a look here at the smoke from the wildfires at the end of July. This was July 18th. And that smoke just curled around that big high over the west and came all the way over the state of Illinois. Now listen carefully. We've studied this smoke, and it turns out that the smoke that we got from these fires ended up during the month of July contributing to the cooler temperatures we saw. The estimation is that anywhere between 2 and 7 degrees cooler than average on the daytime highs because of the thick smoke in the atmosphere. Now there's another problem with this though. That smoke, and one of the worst fires is this one right here. That smoke at times was really effective at kind of depleting our direct sunlight. This smoke from Oregon went all the way up into Manitoba before turning to the south and covering the state of Illinois. And do you remember those time periods during July, where if you look to the west when the sun was setting, the sun set several degrees above the horizon into those deep reds? That was from smoke from this fire. Some of those fires out west will actually produce what are called Pyrocumulus Clouds. That's where you get these massive cumulus clouds that sometimes get to be 60,000 feet above the fire, born on the heat of the fire. They don't make much rain though. Instead, they produce a lot of lightning, which starts more fires. But let me give you another number here. If we saw a cooling effect from all this smoke we measured, we also saw a pretty sizable reduction in the total amount of direct sunlight. And over the state of Illinois, I'm just going to write the number on here, it was 15%. We saw a 15% reduction in direct sunlight. It was diffuse, so we saw a 15% reduction in direct sunlight. While that impacts corn, it really had a bigger impact on soybeans. And some of the early estimates, although this is purely an estimate, was that we saw about a 3 bushel loss on our beans on average across Illinois this year because of that. Now, it was still a good year, but the 15% less direct sunlight was very problematic. So these are just a couple things happening in summer. And those western wildfires, which they do a tremendous effort in fighting. Watch this video here. This is an aircraft that's scooping up a bunch of water here. It's going to just barely miss the shore. Ready for this? That's incredible. This is just a target practice to work on putting out these fires. But if these fires like this continue in the West year on year, it's something that we're going to have to pay attention to because it affects our high temperatures and it affects our insolation. That's how much light comes from the sun. So at the same time, by the way, just want to point one other thing out. That big ridge we saw this past summer impacted our friends to the north as well. Throughout the Canadian prairie, they had their driest summer going all the way back to 1979. And generally speaking, Canada, the Canadian prairie, has seen an increase in precipitation to the tune of about 1.5 inches. But this is one of the driest summers they've had. And if I just show you those areas that saw less than 5 inches of total precipitation this past summer, there was extremely dry conditions in Alberta and Saskatchewan here that had a major impact on the crops in this region. So we just have to see that that drought didn't just sit over the United States, it was pretty far to the north as well. Ironically, this pattern this fall has completely shifted away from where it was over the summer. Now the jet stream over the last week to 10 days has just targeted British Columbia with 200-mile-an-hour winds about 6 miles above our heads. And as that wind came on shore, after having one of the driest summers on record, especially in British Columbia, they then flip-flopped over to now having in about an 8-day time period at the end of November, beginning of December, where they picked up over 20 inches of rainfall right here on the coast. So remember what I told you at the beginning, the state of Illinois, in an entire year, we typically get on average about 40 inches of rainfall. They got half of that in 7 days here along the coast of British Columbia. Some of these storm systems were absolutely massive. This was one of the biggest ones back at the end of October, just barreling toward the Pacific Northwest. When that one brought all this moisture into California, look at what it did. British Columbia liquefied the soil, ruined these railroad tracks. They're still cleaning up after this disaster. But coming back to California, remember me telling you about Lake Oroville? That one event added 40 feet of water to Lake Oroville, which is a tremendous amount. But Lake Oroville is still about 110 feet lower than it was in 2019 and about 200 feet lower than what it should be for discussing the climatological average. But having that jet stream pretty far to the north gave us a very dry, November. And that followed an extremely wet October. So I'm showing you this so that we can be thinking about precipitation variability. Let's get into a discussion about that. Because one of the most important long-term trends that affects our temperatures and our precipitation variability is shown here. Now, if you've seen me present this research in the last couple of years, I'm going to show it to you again, because it's probably the most important study I've read about climate variability across the United States. It's from the journal Nature, which is a peer-reviewed and very prestigious journal. They looked back over 70 years and they found that along the west coast of the United States, now listen carefully, the frequency of ridging events in summer is increasing. And if it's increasing there, because of the typical wavelength of the jet stream pattern, we have more troughs over the Great Lakes. That's critical, what you see here. Because if we produce more frequent ridges in the west, that means there will be fewer M's in the Midwest. No, whoa. Fewer inverted V's in the Midwest. I'm so sorry. I was sitting here thinking about which one I was going to say. It's fewer V's. We have more M's, more cooler summers, because the West is taking on the heat. That's, to be honest, might be the most important thing I share with you today. Because when drought expands in the West, it usually does not expand in the East. And this is what our current drought monitor looks like right now. Now, something I want you to pay attention to. I'm gonna come here. This region down here in Texas, we have seen an increase in this area of drier and drier conditions as of late. If that is not corrected, I'll be worried about it next summer coming in Illinois. Just wanted to point that out for you here. But when we talk about all of this, I really want to answer the question, why? Why is the West seeing such extreme temperatures? Well, one of the big reasons is the North Pacific Ocean since the 1970s has seen an increase in total heat content by a lot. And if the heat comes into this part of the ocean, guess what the jet stream has to do? It has to go around it. If it goes around it, it ends up diving over the Great Lakes. So it's the excessive heat we're putting into the North Pacific Ocean here that is really starting to reduce the risk of extreme heat in the Midwest. It does not mean we won't have hot summers. It just means that there's a greater frequency of those hotter summers being in the West. So 88, 2012, they're going to happen again. But the frequency of those events is not nearly as high as it is across the West. And by the way, if you go out to California and ask those folks, when was your best year? You know what years they pull out? 1988 and 2012. So that tells you how the relationship is between the jet stream flow across the West and the Midwest. So let's put some other numbers to this. Looking at our growing season here, April to October, I went out and looked at minimum temperatures, which we've already discussed, and that value precipitable water. What we've found is that since 1970, total precipitable water amounts have increased 15%. And when you add another decade, I only showed you the 80s before, you add another decade, our overnight lows since 1970 have increased about 3 degrees Fahrenheit. What that all means is things are getting a bit juicier here. The atmosphere has more water vapor into it. Now the relative humidity increases about 6%, but relative humidity is a useless term overall because it's relative to temperature. So we would expect to see that increase given the overnight lows increasing. But I'm going to come back to what I told you a few moments ago. I'm trying to understand what this means for temperature and precipitation variability. So for the whole of the corn and soybean belt from April to October, and this number matches what it is for Illinois, we've seen an increase of 5.5 inches of rain since 1948. So looking back about over 70 years, we've seen an increase in our total precipitation. What's the increase come at the expense of? Well, in the state of Iowa, the frequency of those big rainfall events where you get more than 2 inches of rain in a day has tripled. In the state of Illinois, using radar data to measure this, we've doubled it. So that means that yes, it's getting wetter overall, but the way that the precipitation is being delivered is in bigger one-off events followed by longer stretches of drier weather. And our new climate normals are reflecting this. You know, this is showing you the long-term trend when we updated the new climate normals to get rid of the 80s and add the 20 teens. And what you notice here is that, generally speaking, you get on this side of the Continental Divide, roughly speaking, it's a lot drier in the desert Southwest in California and getting up here toward the Columbia Basin. Meanwhile, east of the Continental Divide, nearly every location is measuring an increase in total precipitation annually. Now, I've shown you this before, but I'll bring it up again. At the beginning of 2020, I was on Twitter, and this young guy named Andy Zessin posted a question to farmers that were in the Midwest. And he said, what on-farm investment has the highest ROI? And if you've heard me say this before, it was pretty funny because he had a lot of responses. Look at this, 188 people responded. The most common response was to marry rich. That's your best on-farm investment. The second most common response was to put in tile drain, and that was to help manage that water. So this is practices being put into place because of the shifts in climate that we're seeing. All right, are we seeing more variability at the end of the year? Well, just take a look at the last 2 years. This was mid-October last year in 2020. Soil moisture values from California all the way to Pennsylvania, New York were sitting between 2 and 5%. Do you remember how dry harvest was last year? If you don't, I'll remind you. We had that flash drought set up, and this was a picture taken over by Bloomington here. And you can see the scar across the field where it burned. And I've been showing this picture now since that point, just to show you that fires were racing through Minnesota as well, and parts of South Dakota, where we've got here, a fire went through a cornfield, just burned everything off. And it was kind of funny. I maybe told you this before, but when this picture came out and I showed it to my son, now he was 8 years old at the time, but he said, Dad, how come that corn didn't pop? And I said, well, son, let's have a discussion about field corn versus popcorn and sweet corn. So we finally got to learn about that, which was pretty fun. But look, that was 2020. This was October 2021. We had several climate reporting districts in the state of Illinois and Indiana and Michigan here that had a top 5 wettest. So that variability is high and increasing, and that's what I want you to know about. That was what we were discussing here. So I always show this video. I've been showing it for 5 years, but it's a reminder to everybody. Efficiently managing water is the most important thing you can do to improve soil health. It's the most important thing you can do to become climate resilient, is to manage the water and manage it well. Whatever those practices look like, if they are a tillage practice, if they're cover crop, if they're putting a different style of drainage or saturated buffers, whatever it is, it's about water management. That is the key. And I'm not telling anybody on this call anything they don't already know, but I am putting the numbers in here so that we can see what those changes are. Now, in the next 3 minutes, we're going to ask the question, is severe weather changing? Because we can get some nasty storms across the state of Illinois. Our most common type of storm is called the squall line. Produces a big shelf cut like you see here from Minnesota this past year. Well, when we look longer term, we just don't have enough data to tell you what the trend is. We just don't have enough data. And the frequency of data collection is changing because there's more people reporting severe weather events. But 2021 was down compared to average about 10% on those severe winds. It wasn't as though we didn't have those events. I mean, let me take you back here to August 10th. The night of August 10th, we had severe storms that ripped through northern Illinois and then appeared the next morning in western Illinois. This radar animation shows you some of those nasty storms. By the way, I was looking closely at what those storms look like on radar. I got to show you this. Here comes the storms the next morning through western Illinois. But when the sun rose, see these little rings showing up here? Watch it one more time. Watch right over here. I'll point the mouse at it. See that ring? That's actually where our radar network was detecting birds leaving roost early in the morning. Pretty amazing to see that, right? But I'll tell you, that stretch of days there at the beginning of August was nasty. Each one of the black circles you see here was a separate severe weather report, and it did a lot of damage to the corn crop in northern Illinois. And so this is one farmer that had complete crop loss here in this part of his field, did too much cell damage to that to the corn stalk there for it to recover. On hail, well, hail this year, way down compared to average, 45% of normal. Don't expect that for next year. We did have some pretty nasty storms that came out of the northwest over that big ridge, but most of them hit to our west. Some of them came into western Illinois where we saw some crop damage. This was actually in Iowa, but this was not a year for major crop damage due to hail. Just a quick reminder, if you're looking at your local radar app, and my favorite is Radar Scope, by the way, look for the pink and purple, because this year in Fort Worth, Texas, see the supercell and the little pink and purple shading right in there? That hail core went over some of the northern suburbs, did $1.5 billion in damage. They estimate that it'll take 3 years to repair all the roof and all the siding that was destroyed by this particular hailstorm. And we know that pretty well over here in East Central Illinois, right? We had the hailstorm back in early the growing season in 2020, and we expect still places to have their roofs replaced this fall, still cleaning up after that disaster. All right, finally, tornadoes, and then we'll move on with this, okay? When you think about tornadoes, again, we do not fully understand the trend in the count of tornadoes. This year was about 90% of normal, but most of the big ones were down south in the lower Mississippi River Valley. Brian Empfinger was chasing this one back on May 2nd with his drone. What an incredible video of one of these powerful tornadoes. We do know something, though, about tornado research with respect to climate change, and I want you to see it. It's right here. Victor Cassini from Northern Illinois University got a paper published in the journal Nature. Again, very prestigious journal, where he looked at the change in favorable tornado days from 1979 to 2020. And this is what he discovered. If you are along and east of the Mississippi River, oops, sorry about that, along and east of the Mississippi River, the frequency is increasing. The positive numbers are shown in these colors down here. So we are seeing more favorable tornado days east of the Mississippi than we did in the past. What that means is Tornado Alley shifting, and it's shifting to the east. That's some really solid research out of Northern Illinois University. And in 30 seconds, what about hurricanes? Well, we didn't have any hurricanes that delivered moisture to us this year in the state of Illinois, but we did exhaust our name list once again, going up to 21 names. The worst by far was Hurricane Ida, which you see here gaining strength up to Category 4 intensity. When Ida came on shore, pushed a bunch of water into New Orleans, and that rain getting pushed around by 80-mile-an-hour winds here coming through the central business district of New Orleans just produced a scene like this, which lasted for several hours. Why I'm showing you hurricanes this year, even though we didn't have any that really majorly influenced Illinois, was because I want to show you what happened on the Mississippi River in Louisiana. Normally, the discharge rate of the river is about 350,000 cubic feet per second. See this right here? That was when the winds from Ida pushed against the flow of the Mississippi River, stopping it. The discharge rate went negative. The water built up about 9 feet during that time period, and then once the hurricane moved on, the discharge came out at around 500,000 cubic feet per second, and the water level went back down. But those hurricanes got enough wind in them to stop the mighty Mississippi River. Isn't that incredible? All right, thinking about all of that, where I want to finish with this today is I want to talk about wind, because we've had some brutally fast winds, and you're about to get even more here in the near term. We're going to have very strong winds coming around this cyclone that's happening here in the next 24 hours or so. But this was a week ago. I was up in Great Falls, Montana, right up here, just getting some brutally strong wind. And I got asked a bunch of questions about wind turbines. And I thought that'd be an interesting place to stop today, because I saw this newspaper clip. This was sent to me out of Idaho Falls, Idaho. And if you're reading it with me, it's hilarious. The guy says, enough with the wind already. Jeff Forbes, ever since they installed all those big fans up on the hill, it's become even windier. Whose bright idea was that? I've noticed when they're off, we get a nice calm spell. Please turn them off, at least on the weekends. Now, I don't know if Jeff was writing this op-ed just to be funny, but if not, there's clearly a lot of misunderstanding about how wind turbines work. And what I'd like to show you here at the very end is what we've learned about them. Oh, by the way, I just had to show you something. Those winds we saw in Great Falls caused a major fire up there. Power lines hit this grain elevator, caught it on fire, and it actually burnt 10 homes in the town of Denton. So it was pretty nasty. But I want to tell you what we know about wind farms, okay? So listen carefully as we wrap this up today. These wind farms, when we look at the big wind farms, what they are very effective at doing is called mixing the lower atmosphere downwind of them. So the wind turbine, especially overnight, is very good at mixing out inversions. So you know what an inversion is, right? Every night when the sun sets, we get cold at the surface. In fact, that was what caused the massive fogs throughout parts of Illinois this morning, okay? Those inversions tend to set up where it's cold at the surface and warm a couple hundred feet above the surface. What we've learned is that the wind turbines get rid of the inversion just downwind of them. That was published in the journal Science. So they've studied how that works. And here's the other amazing thing about them. We had an event that was just recently published in this preprint here, which is going to go out in full publication soon, where in Texas, the Texas Panhandle, we had a storm that was going toward a wind farm. Now look up here, I'm going to draw on this. This is the wind farm here. And you see this fine line on the radar right there? That's the outflow or the shelf cloud on the storm. All the heavy rain is back here. Now what's happening is from panel A to panel B, they zoomed in on the wind farm. And that's what each of these dots is here in the bottom diagram. Now what was amazing was the wind farm did this to the outflow boundary. See that kink? As the storm progressed this direction over the wind farm put a drag on the speed of the wind, effectively forcing the storm system to not only change direction, but to curl around the wind farm just like that. No, I do not have an answer for you as to whether or not wind farms are causing a shift in precipitation patterns. We're actively studying this right now. We don't have an answer, but there's evidence based upon radar data that it is. So we talked today about why Illinois is so well suited for growing corn. We talked about the length of the growing season and its changes. We covered spring precipitation and temperature changes. Basically, it's getting wetter and a bit warmer. That's lengthened our growing season. We looked at summer. We know that we want to avoid the inverted V's and bring on the M's, and that the historical changes across the West are giving us more frequent favorable summer conditions. But our rainfall frequency is increasing. We're seeing more big rainfall events followed by longer stretches of drier weather. And as we then work our way toward fall, where we tend to get a lot of our severe weather in summer and late fall, and then toward the hurricane season, that there are shifts there that we need to pay attention to, like the frequency of tornadoes east of the Mississippi River Basin. All of this comes together to give us an understanding that in the state of Illinois, the net effect of the changes we have seen over the last 70 years have been positive, but it comes at a consequence of other locations. Now, that was 48 minutes of me talking about climate shifts and weather. I wanted to leave 10 or 12 minutes if you have questions about this that I could provide some answers for. But that's what I wanted to share with you today. So I'm going to wrap it up right there.
Thanks, Eric. I'm going to go ahead and unmute everyone. So just be prepared. Your line will be open. If you guys have any questions, feel free to ask or type them in the chat.
Yeah, sometimes after a talk like this on a Friday morning, given that many statistics, the questions don't often pop out right away. So I'm going to tell you what I'm going to do. I'm going to go back. Hang on just a second here. I'm going to go back to my my first slide. If I can get there. There we go. And make sure that you all have my email address. It's just eric.snodgrass@nutrien.com. Please feel free to ask away and email me any questions you may have about this stuff, because they might pop up here in the next couple of hours as you think back to what I shared with you. But did any of them come in?
No, and Eric, I am having difficulties. It's not letting me unmute. So guys, if you do have a question, please type them in the chat or feel free to try and unmute yourselves. You should have that option as well. Looks like Rod's been able to unmute. Rod, do you have a question?
I can't hear him if he's talking.
Oh. All right.
Hey, by the way, since there are no immediate questions, I do want to show you something kind of interesting. So something big to think about here. When we get into this upcoming fall, this upcoming winter, I do want to show you the number one thing I'm on the lookout for. Now, first of all, remember, next week, very mild. We're going to have some warm weather. The polar vortex is not disrupted, but take a look at this. Ready? What I'm showing you here, if I can get my screen to play full, there we go, this is what the forecast looks like from December 20th to January 20th. So we're looking at above average precipitation, and there's a lot of cold on our doorstep. Now, I was goofing around last night in my forecast video, and I went out there and looked at what Christmas looks like, okay? So everybody says, what's the chance of a white Christmas? Well, climatologically speaking, in the middle part of Illinois, it's about a 33% chance. In northern Illinois, it's about a 40% chance. And in southern Illinois, it's about a 15% chance. But this year, with all this cold air knocking on the door in the Canadian prairie, we need to be on the lookout because the models are suggesting a very active time period with respect to precipitation. So we're going to go into winter very, very active. But what I'll finish with is this. This La Nina right here, it's done. It's at its peak. It's going to start to fade. It'll be around for another 4 or 5 months, but it's fading quickly through spring, fading quickly into summer. And those changes as we get into spring and summer are really going to start to be felt once we get out here to about June. Because in June, we're already starting to see warmer water emerge right in through this area. And if I could just put one last thing in your heads here about the United States, if we end up having a bunch of cold weather along the West Coast in summer, this does increase our risk for higher temperatures and lower precipitation. But I'm going to put a big question mark on this as we have a lot to see evolve between now and this upcoming spring and summer. As it currently stands, it looks as though we're going to have another good year next year. But I'll be watching this colder water in place here and the fading La Nina and the emergence of possibly a weak El Nino by the time we get out there. And by the way, if you're worried about what's going on in South America, I'll just make a quick point about it. In South America right now, they got their first crop of soybeans in very fast in Brazil's northern growing areas. We're worried about Rio Grande do Sul to Paraná, that's right in through here, and Argentina. Because all the way out to mid-January, this region is expected to get dry and stay dry. And if you are unaware about how big of a growing area we have here, this is the state of Mato Grosso. People often call the state of Mato Grosso the ice states of South America, but it's so much bigger. I can actually fit 5 Iowas and 1 Tennessee inside of the state of Mato Grosso. So it's a very, very large growing area. And Megan, if I do one more thing here, I can give you something for free today.
Great. And we do have 2 questions, but let's
good. You go to the questions then.
So the first one is, from the data you presented, it looks like cover crops and no-till would be good practices to implement.
I would say not only yes, because of the effect that it has on reducing soil erosion, but I mean, we're all pretty aware that companies are starting to pay us to do that, right? I mean, Bayer rolled out a program, which Nutrients is a partner of Bayer, and they rolled out a program where they're paying either $3, $6, $9, or $12 an acre based upon implementing reduced till, strip till, no-till, cover crop application, and there was one other thing. I don't remember what it is off the top of my head. So we're paying for these sustainable practices, which we also use because it stores carbon. And you know, the carbon is stored in the plant only in the roots. The stuff that's above the ground doesn't store carbon. It's only in the roots. So yeah, you're 100% right there. I mean, if those practices increase yield and ROI, we do them for multiple reasons. So yes, absolutely yes.
Another question, does the large increase in cloud seeding in China have any effect on our weather or the ocean temperature in the Gulf of Alaska, which would affect our weather?
Oh, I love that question. Cloud seeding is very effective, but only in very specific places, okay? I don't know, I'll just come in here and I'll pull up a map like this. Okay, where we effectively seed clouds in the United States is on the Cascade Mountains in the Northern Rockies. Cloud seeding does not work on the plains, so don't do it in here, because if you seed a cloud in Nebraska, it may blow clear to Illinois before it makes precipitation. But over the mountains serve as a permanent barrier to get the air to rise. And we studied this at the University of Illinois. We named the project Snowy, that was its name. And they went out and found that between a 5 to 25% increase from here in Idaho, because Idaho Power cloud seeds every single year. Now, your question was about China. Now, I'm sorry, but we get terrible information out of China, and they will often say that things they do are very effective when there's no scientific research to back it up. If they are not seeding clouds near mountains, the effect is negligible. We actually can't measure it. So you say, is it affecting things? Is it affecting the Pacific Ocean, the ocean temperatures there? The answer is no, it is not. It wouldn't translate that far. It couldn't get from China to the Gulf of Alaska. So I know they're doing this right now for the Winter Olympics, trying to clean up the air, because honestly, fall and early winter is the worst time of year for air quality in China. But the short answer here is they are over exaggerating the effect of their cloud seeding. And I'm only saying that because there's no peer-reviewed publications to prove otherwise. That's not me saying something bad about the Chinese. I'm just saying prove it with a peer-reviewed publication. That's what I want to know. Great question there, but big opened answer.
So you talked a little bit about the wind turbines. Do these wind farms reduce storms or divert any storms?
Yeah, well, we don't know if they reduce storms, but the point of me showing you that thing at the very end of my presentation, which was right here, was that we are measuring them with radar, having an effect on slowing the storm down and changing its course. But this is inconclusive. I could not tell you. So for example, the nearest big wind farm to me is the one that's probably in Bloomington. I have no scientific evidence right now that that's affecting the storms. We're still actively studying that. But I'll tell you this, we can see it. I'll just pull up my favorite radar app here. This one's called Radar Scope. And take a look. Let's get this pulled up. There we go. There's the wind farms. That's the one that's just south of Clinton. So if I animate this, you'll see this is where the radar is hitting those wind farms. So we're trying to understand what kind of effect this is having. And it's inconclusive at this point. That's what I want you to hear.
Great. Well, those are the questions that I've had show up.
Okay.
Did you still want to show that link you were talking about just a minute ago?
Oh, yeah. If anybody wants, yeah, I get to produce weather content every day that goes out for free. And if you're interested, it's just right here. And again, you can just sign up for it. You can unsubscribe at any time, but it's info.nutrien.com/Snodgrass_weather. I'll make sure, Megan, that you have that link. But all that it does is it puts in your inbox every day an email with the weather forecast information that I've got. And in 2021, I'm going to be releasing brand new field specific stuff. So I'm trying to find my email this morning. There it is. And this is what it looks like. So you got a downloadable report if you want to see it that goes across the nation and looks at the weather variables and how they probably will affect the markets. It's about 9 slides long, showing you all the big stuff there. And then it also just goes through some of the details about the forecast, gives you videos, gives you some of the most important maps. And that's about it. That's all the reading you'd have to do to kind of get through most of it. The rest of it's just my favorite maps here. So yeah, just want to put in a plug for that. Thank you.
Well, thank you again, Eric. I really appreciate it. Reminder, this was recorded. We will be getting it posted out to our social channels and our website shortly. But thank you again, everyone, for joining. And Eric, we appreciate your time today.
You are absolutely welcome. Thank you.
Bye, everyone.